All right, today we're going to be going over quadratic inequalities. We're going to start off by graphing these quadratic inequalities. Up here on the top, it's telling you that in order to sketch the parabola, you are going to sketch it just like if there was an equal sign. Nothing changes on that part. What changes is whether it's going to be a solid line or a dashed line. It will be solid if there is an equal sign on your inequality signs. It is dashed if there is no equal sign. So equal sign, make it a solid line on the parabola. No equal sign, we make it a dashed line. Then we're going to test a point inside of the U shape and one outside. And that test point is going to tell you where you need to shade. We're going to start by showing you on the calculator, and then I'll show you how to do it by hand. So we're going to start with this one right here. Y is greater than x squared plus 3x minus 4. Looking at this, there's no equal sign underneath this sign, so I already know it is going to be a dashed or dotted line. Now, to graph this, I can go ahead and put this in exactly the way we have in the past, x squared plus 3x minus 4. And then we graph it. Here is my parabola. I need at least 3 points to graph my parabola. It's asking for the vertex and axis symmetry, so I'll go ahead and review with you guys on how to find that using your calculator. You hit second trace, and you want to go to minimum, since that is a quadratic that opens upward. It's concave up. For the left bound, I'm going to go somewhere on the left and hit enter. For the right bound, I go somewhere on the right of my graph and hit enter, and then enter for the guess, and it tells us it is at negative 1.5 and negative 6.25. So there is our vertex. I would go negative 1.5, negative 6.25, and there is my graph. Sorry about that, you can't see that. There's some extra markings here, let me remove. All right. So there is my vertex, and now we are going to find the axis of symmetry. Well, we know that goes right through the vertex, so I'm going to have my axis of symmetry here, just so that you guys can see that. And that is x equals negative 1.5. Notice that these are both the same. The axis of symmetry cuts right through that vertex. So now we've got a vertex, and we've got our axis of symmetry. We also need some more points here to graph. We can go ahead and use our table for that. And so we've got a point here at 1, 0. And then we've got another point at negative 3, negative 4. And negative 4, 0. Whatever happens to one side also happens to the other, so we have that point there, which we knew this point as well, since that's the y-intercept. Since this is in standard form, we know that negative 4 is the y-intercept. And so there it is. All right, now we're ready to graph this, and we said it's going to be a dashed line, so we can go ahead and make our dashed line through this quadratic. We have graphed this. We've got a dashed line on that parabola because there was no equal sign, and now we're ready to do the shading. And so we want to test a point. You can test a point on the inside and the outside. Inside of my parabola here, I have 0, 0. That's usually the easiest point to test, so that's one of the ones that you're going to want to go with. So I'll start with 0, 0. I plug in 0 for the y and 0 for the x. And what we're doing by plugging this in is checking to see if it makes a true statement or not, because that's where our solutions are going to be found. And so that gives me 0 here and negative 4. That says 0 is greater than negative 4. That is a true statement. So wherever 0, 0 is, that's where my solutions are. So 0, 0 is inside of this parabola here. So my solutions have to be found inside of the parabola. So I would shade on the inside. We talked earlier about linear inequalities, and we said the calculator could graph those. Well, the calculator can graph this as well. So I will show you that while I'm here. When the y is on the open side, which means it has one of these two symbols, then you are going to look for the little triangle on top in the calculator, and I'll show you that in a second. When the y is on the less than or less than this way, it is the little triangle on the bottom in your calculator. And I'll show you that so that you can see it, what it looks like on the actual calculator. So here is our graph, and I don't want to get a glare on there. That's still kind of clear. All right. So we are going to go to our y equals, oh, that's still got a terrible glare. There we go. Where we have our equation in the y equals, I'm going to move this into on the other side of the y equals. I hit enter. If you've got one of the older calculators, every time you hit enter, that is going to change. If you've got this newer one here, it's going to give you the little menu right here. And so instead of a line, we are looking for those little triangles. So there's that greater than, y is greater than, and there is the less than. So triangle on top is the greater than, triangle on the bottom is the less than. And this is y is greater than. So I want this triangle on the top. I hit OK for the clear. And then I go ahead and graph it, and it shades it for us, which is exactly what we thought it was going to shade on the inside. All right, I'm going to go back to my graph here, and I'm going to go ahead and try another point so that you can see a test point on the outside. So you would pick any point anywhere on the outside. I'll do it up here. And I'll go ahead and test 3, 0. That's clearly on the outside of that graph. You can pick any point on the graph as long as it's either on the inside of the parabola or the outside. So I pick 0 on the outside here, and I get 0 is greater than 3 squared plus 3 times 3 minus 4. I plugged in the 3 for the x's and the 0 for the y. That's going to give me 9 plus 9 minus 4. 0 is greater than 18 minus 4, which is 14. That is false. That is not a solution because it did not yield a true statement. And so when we simplify this, we find that 3, 0 is not a solution, which is out here. So this outside part would not be shaded. All right, we're going to go ahead and try another one here. And this one I am going to do it without the calculator to make sure that you know how to do that. So we've got the standard form here. Again, it's going to be dashed because there is no equal sign there. We've got a couple different ways that we can graph this. We've got a y-intercept of -8, so I know that point. Now, in order to graph this, I really need more than just one point. And so I've got to find some more points from here. This is one that can factor, so I can go ahead and factor that and find our roots. So to get x squared, that's x times x, and then we're looking for what multiplies to be -8 and adds to be 2. Well, that's +4 and -2. And so my roots have to be -4 and +2. So now we've got 3 points. We could technically go ahead and graph that, but I'm going to go ahead and review on how to change this to the vertex form so that you have that as well. And we do that by completing the square. So I'm going to go ahead and complete the square with these first 2 terms. I take that middle term, divide by 2. So that's 1, and then square it, which is 1. Now I just added 1 to the equation, so I need to subtract 1 from the equation. I go ahead and factor this, and I get x plus 1 squared. -8 minus 1 gives me -9. And so now it's in the vertex form. And my vertex here would be -1. Remember, that's supposed to be x minus h. So -1 is the x value of the vertex, and -9 which is this one right here, is the y value of the vertex. So -1, -9 is my vertex. The axis of symmetry would have to cut right through that point. Since that is the vertex, so we get x equals -1 as my axis of symmetry. Whatever happens to the right must happen to the left as well, so we get that point. And we said this was going to be dashed, so we go ahead and make our dashed line. Again, 0, 0 is the easiest point, so I'm going to go ahead and use that one. I plug in 0 to my equation, and I can really plug it into either one of these equations that we have now written. We wrote all three forms up here just for practice. So I plug in 0 for the y and 0 for the x, and I get 0 is greater than -8. That is a true statement. So wherever 0, 0 is, which in this case is inside my parabola, there are my solutions. And so we have graphed our quadratic inequality here. All right, I'm going to go ahead and do one more. And again, for this one, I'll use the calculator just to graph it since it's in the standard form, so that we don't waste the time there. 2x squared minus 3x plus 1. And then I'm going to go to my table to find some points. When you're looking for points there, you want to see where it goes down and then back up. So at -1, all right, so we've got kind of a small parabola here off to the side, and it has an equal sign under here. So this would be a solid line. And so I've made my solid line through the parabola. Now to determine where I am going to shade, I want to make sure that I pick a point that's outside of the parabola. 0, 0 is on the outside there, so I can always pick that point. But I do like picking a point that's way out just so there's no confusion. So I'm going to go ahead and pick -2, 0 here. I plug in 0 for my y and -2 for my x. And so that gives me 4 is the squared part here, times 2 is 8. -3 times -2 gives me a +6, and then we've got that +1. And so 8 plus 6 is 14, plus 1 is the 15. 15 is greater than or equal to 0. That is true. So wherever that point is, that's where my solutions are. And so these are on the outside part. So I would shade the entire outside part. All right, now we're going to talk about the one variable quadratic inequalities. So in this case, we've only got an x. We do not have a y, so we would not use a coordinate plane to graph these. But we do want to discuss on how to solve them and graph them on a number line, which is where you would graph them. Just like when we were solving quadratics, we want to get it equal to 0. That's what we want to do here. So we're going to want to subtract that 15 to get it to the other side. So that gives me x squared minus 2x minus 15 is greater than 0. I now factor this so that we can find our critical points on this. And so we're looking for what multiplies to be -15 and adds to be -2. Well, that's -5 and +3. -5 times 3 gives me -15. -5 plus 3 gives me that -2. Hopefully you're getting really good at factoring at this point. And so the two roots here are 5 and -3. We are going to make a number line now, and those are going to be my critical points. I've got a point at -3 and a point at 5. If there's no equal sign, it's going to be an open circle. If there is an equal sign, it's going to be a closed circle, kind of like the solid and dashed lines. So both of these are going to be open circles here. Now we need to determine where are our solutions in these different areas. So just like we did on the other side, we would want to test a point in each one of those sections. I still think 0 is the easiest, so I'm going to test 0 right here. I plug in 0 here and I get 0 squared minus 2 times 0 is greater than 15. That's 0 is greater than 15. That is not a true statement, so my solutions are not found in the middle. When they're not found in the middle, they're really found on the outsides, but we would want to test a point in each section. So I'm going to test 6 on this side here, and I get 6 squared minus 2 times 6 is greater than 15. So that's 36 minus 12 is greater than 15. 24 is greater than 15. That is a true statement. So that is where my solutions are found. I do the same thing on this side, and so I'm going to do -5 on this side, and I get -5 squared minus 2 times -5 is greater than 15. -5 squared gives me 25. -2 times -5 gives me a positive 10. And so that is 35 is greater than 15. That is also a true statement, so we have solutions over here too. If I wanted to represent this graph as my solution set, I can say two different things. I can say negative infinity to -3 with both of them using parentheses, and the union of 5 to infinity. That would be my solution set if I did it in interval notation. And then if I did it in inequality, I would say x is less than -3 and x is greater than 5. So there is our answers for those. We'll go ahead and try one more together. In this one here, I would want to get rid of the negative in front of the x squared. So I'd like to get rid of that by dividing the whole thing by negative or factoring it out, one of the two. So I'm going to factor out this negative, and I get x squared minus 2x minus 8 is greater than 0. I then factor my trinomial here. X times x gives me x squared. What multiplies to be -8 and adds to be -2, that would be a -4 and a +2. And so my two roots are 4 and -2. I'm going to get those graphed on my line here. That 2 has no equal sign underneath it, so they would be open circles here. And then I start to test points. So I'm going to plug in a 0. Again, I still think that's the easiest. And so we get -0 squared plus 2 times 0 plus 8 is greater than 0. That gives me 8 is greater than 0. That is a true statement, so my solutions are found in the middle. If they're in the middle, they're not going to be on the outside, so that's really all of my solutions there. If I want to write this in interval notation, I would use the parentheses from -2 to 4. If I want to write it as an inequality, I would not use the equal signs there, and I would say from -2 to 4.